Hello everyone. Welcome to our webinar Qt Lite Overview. My name is Maria and I'm taking care of hosting this webinar. So before Lars and Niels start their presentation, I would like to take just a minute to mention that this session is being recorded and we'll be sending it after the webinar to all registrants. We'll have the Q&A section at the end of the presentation, so feel free to submit your questions to the question box. And now I'm happy to turn the floor over to Lars and Niels. Enjoy the webinar.
Hey, thank you very much for that, Maria. So my name is Nils Christian Rocher Nielsen, and I work as a product manager here with the Qt company, and I'm here today to talk about Qt Lite together with my colleague Lars Knoll. Maybe you can introduce yourself, Lars.
Yes, good morning or good evening wherever you are. My name is Lars Knoll. I'm the CTO of the Qt company and also the chief maintainer of the Qt project. So while Niels will be doing a little bit of talking us through the product slides at the beginning, I'll do a little bit more of a talk through some of the technical details around the Qt Lite project, how things work internally and how you can also use that to your advantage in your project.
Yeah, that's great. So just as we start, as Maria mentioned, we will do some Q&A. If you notice, there is both a questions and a chat section in the tool here. So feel free to ask us questions. We'll try to monitor that. We'll try to get back to you with answers to most of those questions, but we'll limit the Q&A section to the end of the presentation. So I'm based in California at the moment. We have an office there, and Lars is in Oslo hosting the slides. So maybe if you could move to the next or the first slide, Lars. Thank you. So as you can see from the world map, yeah, I'm in Santa Clara. That's where we have our US office, but most of our development is done in Oslo, in Berlin, and in Oulu in Europe. And that is also where the Qt Lite feature that we will be talking about today have been developed. But I quickly just wanted to mention a little bit about the Qt company. Some of you may have heard of us, either through the Qt company name or other names. We are the continuation of what was called Trolltech, and we have been through a number of iterations of companies, but we are the same people, and we are solely focused on developing Qt to be the best product it can possibly be. And now, since May of last year, Qt company is an independent company working only and exclusively with maintaining and developing Qt. We have a large user base of Qt users, and we have more than 20 years of experience with actually working with Qt. So here we have a 2015 revenue number. We are not fully finished with all the bookings from December, so we don't have a public number to go out with yet for 2016. But I can tell you that we've had some good growth as we've planned and as we've indicated before. And we're hoping to sustain that also through this year, continue to grow and be a very relevant company that can really accelerate the growth and the features of Qt. And that, I think, is mainly what we're here to talk about today, some of those new features. So if we move forward. What we are talking about today is really how we can solve some of the challenges that we see in the marketplace today. And the probably biggest challenge and opportunity that we see, both for ourselves and for you guys as well, is that there is an increasing discrepancy between the numbers of devices being put out to the market and the developers that are going to produce these devices. Now, as you can see, most of you are probably engineers listening into this. There are no numbers on the axes here of number of connected devices or number of developers, because many of these are estimates and different corporations or different agencies are giving slightly different numbers to these trends. So it's not entirely clear, but we're talking about a very, very rapid growth in the number of connected devices that are being put out to the market. And whether that's 50 billion or 60 billion devices by 2020 is more or less irrelevant, because we see that the number of C++ developers will stay pretty stable at around 4 million developers. It's not growing a lot. So how are you guys going to be able to really accelerate the growth and cater to the demand of the market? And we see this as a huge opportunity for us to help you guys out with better tools, with more features, so that you can spend the time more wisely and get more stuff done. That is the main and the sole focus of most of the things we're doing, and especially with Qt Lite, it's the focus of how can you create more devices with the Qt framework. So we are really looking at how we can increase the usage of Qt and have these nice looking user interfaces power more devices, but also look at how, for example, devices that don't necessarily need a UI can also be powered by Qt. So this is a huge opportunity, we think, both for us and for all of you. Okay, so moving forward, I wanted to give a quick overview about Qt Lite. So I've been the product manager for Qt Lite and have a more or less high-level overview, while Lars has been working on the actual implementation side, and we'll give a more detailed deep dive into the product a little bit later. But what is Qt Lite? We have been talking a little bit about this for a long time. I have been writing blog posts. We talked about this at the World Summit. We've gotten a lot of feedback that this is a nice thing that we are doing, but we still see that many people are not entirely clear or they don't know so much yet, and I guess that's why you're here today. But Qt Lite is a clear focus. It's a clear initiative where we've focused our efforts on making Qt smaller, lighter weight, faster to boot, and to make it easier to create a smooth customer experience so that you guys more easily can use the Qt framework for the products where you need it. We want to enable all of our customers to bring less expensive devices to the market without that taking longer time. That should even be faster. And we want to enable people to work in smaller teams, not necessarily having so many different functions within the teams to be able to bring devices to market. So these are some of the high-level targets that we've been challenging, some of the high-level things that we wanted to solve with the Qt Lite product. And Qt Lite, it is a project that puts all of these challenges really at the center. And what we have done, there's a number of different features that go into the Qt Lite project. It's a complete rewrite of the Qt framework feature configuration system. And that is something we will go into a lot of details of, but it means that Qt Lite goes into the heart of the Qt framework. So Qt Lite is not separate from the regular Qt version. It is not something that's done in parallel with the regular Qt development. It goes to the heart of how the Qt framework works and is configured. And we've created a new GUI tool to work with these configurations and make it simple to use. And for us, that is a very important part of this puzzle. And when we do this, that enables us to target more low-end hardware to run Qt. And by reducing the size of Qt and by reducing the complexity of Qt, we also see that we can achieve much faster boot times for devices. Okay. So when we look at the configuration architecture, the important aspect here is that customers should be able to use only what they truly need. And the whole idea about Qt is that we want to enable customers to have a unified customer experience, a unified corporate identity, if you will, across all of the products they're putting out to the market. So one example could be, like here, a marine navigation device, where they have a very complex and nice user interface on their high-end devices. This is typical use case of Qt, and many customers do things like this. And they might scale this to desktop, and they might scale this to mobile apps, using the same source code to create a corporate identity across all of their devices. Now, what we want, and I think this is a really good use case of Qt, where you can have multiple products, maybe with different feature sets or focus areas or user groups, but still maintain the same code base, still maintain the same implementation of the core infrastructure, but provide different products. Now, to be able to get more out of the hardware, Qt Lite, and if you go one step forward, Lars, will be able to try to scale Qt from these high-end devices to be using the same code base, also to implement user interfaces on much more low-end devices, so that these don't need to be seen as separate projects, but it can be the same project that scales down to target also lower-end hardware. So Qt should be able, and are now with Qt Lite, able to scale across all of the device needs of the development team and of the organization. And this also will allow you to extend the lifetime of such projects so that you can maintain the same code base over a longer time as the project scales from one hardware iteration to another. Okay, I think we can move forward. And I'd like to give just a high-level overview or introduction to the UI configuration tool. So one of the most important things we wanted to do, and one of the things we wanted to change, is how easy and how accessible it is to work with Qt. Not just with the Qt APIs, but to change the Qt framework to fit your needs. And one of the things we've been seeing is that this has been, to some extent, possible for years. What we are enabling now is really groundbreaking, yes, but it has been possible to do changes to Qt before as well. But it has been extremely difficult, and it has been for a select few customers who really take the time and spend the energy to learn and to invest and to change the source code of Qt themselves. We don't think that's feasible when we see this graph I showed earlier, and with that acceleration, with that number of devices, that time-consuming process is not feasible. So we want to bring tools to you that enables all of you to make these changes to Qt in a fast and simple way so that your teams can benefit from that. The other side of this is also to provide the documentation and understanding of what you are doing in a simple way. So a tool, a high-level tool like this, provides an integrated documentation and provides an overview of dependencies, etc., so that you can understand what consequences each of these actions have, much more so than just by fiddling around on the command line with features of Qt that you might not very well understand what does. Having standalone tooling like this also makes it a lot easier to integrate this into your workflow in a simple way. So we hope that this tool, and we see already that this tool provides some kind of democratization of the development process. It's not a special task to be able to configure Qt anymore. It's not some secret magic trick, but it's something available for everyone. And it's no longer available just for the special embedded developers with a special skill set, but we bring this now to every Qt user and developer. So everyone can now be an expert embedded device creator. Okay. So that brings us to kind of the summary of this overview. This has had a very strong focus on embedded so far, and the Qt Lite project really do have that. It is for all embedded devices, and it really makes that simpler to work with. We have for a long time been improving the embedded offering of Qt, and Qt Lite is a continuation of that. So for this first iteration, Qt Lite is something that is mainly available for Qt for device creation product. And with that introduction and overview, I think I would like to hand the floor over to Lars to explain to you more in detail what you can do with this and how exactly you need to do that. So take it away, Lars.
No, I think you got one more slide, actually.
I actually got another slide. Yeah. So focus on the embedded. This is, and I see that there's already a question here. What is the lowest end hardware that Qt Lite officially supports? And this is a great slide to kind of tap into that. There is no hard requirement or no hard specification of this is the absolute minimum, but we do have some targets and some recommendations. And one of the big things here is that we are reducing the footprint of the Qt library, so we can really reduce the total size of the hardware. So 16 to 32 megabytes of ROM for the full image is clearly something that's easy to do. With more work, it's also possible to make smaller feature sets, but the main focus of this is to bring the size down a lot with a little effort, but not to bring it down to an extreme small amount, because we see that as a different type of product. And this is also closely related to the fact that Qt Lite is a part of Qt the way Qt is today. It is not a complete rewrite of the Qt framework. So target hardware are things like the NXP Warp 7. Warp 7 is their wearable reference platform, which is based on the IMX7 architecture, and it has a very strong IoT focus. So devices like this is very simple to use with Qt Lite. Around 1.5 second boot time from cold boot Linux system to the Qt application. That's something that's easy to achieve, and even beyond that, it's possible to bring it down. So we're looking at something like ARM v7 and mainly Cortex-A type architecture. Now, there has been a lot of discussion about the Cortex-M and these ARM M hardware. The M7, high-power M7 SoCs are clearly possible to use with Qt Lite, but there are memory limitations on those that could make it difficult. So some of the high-powered ones might be a good option for that. And one thing that's also important, you don't have to have a UI with Qt Lite, but we've done a lot of improvements to the QML framework. So QML is something that's super powerful to use with Qt Lite. And one of the big benefits and one of the big changes is that there's now there's no OpenGL requirement. This was previously a requirement of QML, but you do not need to have OpenGL hardware, and we've done a lot of work to implement a very powerful rendering pipeline that does not depend on OpenGL with this. So that is the kind of gist of the hardware focus we've had. Compiled QML, static linking, efficient use of C++11, these are the things that make it powerful to use. And then here there's a list: Qt Core, Qt GUI, Qt Quick, QML, and Qt Network. These are the modules that we've had the most focus on so far, and that's something that Lars probably can explain a lot more in detail what we've done there and what that enables you to do.
Yes, okay. Well, thank you, Niels. I'll maybe take a little bit over there, and just to, as Niels said, I mean, you know, we've done a lot of work, and the main focus with Qt Lite has been on the configuration system that I'll go into details in a second. But we have been doing other work as well, like removing the OpenGL requirement to do user interfaces and these kind of things that help you bring the overall resource needs and hardware needs down for your device. But I'll now go into a little bit into the configuration system and try to explain a little bit what we've done there, why we've done it. And to start with, it's probably interesting to note that the configuration system that we've been working on, while our scope and our focus was to enable scaling down Qt and Qt Lite, we've been using the opportunity to revamp the whole system. We had a lot of issues also with the old system. The old system which we used to configure Qt and then build Qt, consisted of a shell script of 8,000 lines of shell code on Unix. With a very repetitive patterns. It was very error prone. There were lots of errors in there, and nobody ever cleaned it up. It's been growing hairs for many, many years. Interestingly enough, since shell scripts don't really work on Windows, we had a second solution on Windows, which was called configure.exe, which was written in Qt and C++ and needed to be bootstrapped. It was somewhat easier to maintain than the shell script and used on Windows. Now, this actually gave us, a little bit of a problem because we had two solutions for the same problem. And what we saw that was over the years, the functionality between the two solutions started diverging more and more. If you configured Qt on Windows or on Unix, you could get different results, even if you configured things for the same target platform, for example, an embedded Linux device. And implementing also the required level of configurability turned out to be impossible with both systems. So we had to sit down a little bit and start thinking about how we wanted to solve this. And we really found out that we needed a completely new system to handle, the configuration, to make it flexible enough to all our needs. And they said, if we need this for Qt Lite, we might as well just do it for all of Qt, and also, use the new system, for example, for the desktop builds of Qt, for the mobile versions, for everything. So we have one single system that we maintain, and to ease also our maintenance load and burden. So what were our goals that we set out in the beginning then? We wanted a very flexible way to configure Qt, the product. Replace and unify the code that we had now in these two solutions, in the shell script and in the exe. I wanted to have one system that works for all our platforms. What we never had was something that could handle external dependencies decently. So, you have a library that you depend upon, like for example, libpng, FreeType, ICU, or whatever. And we wanted to make sure that we could handle those in a good way. Detect them, figure out what kind of include paths we need, how to link against them, make sure that all of that also works very transparently. And also switch transparently between, linking that external library dynamically or, using a built-in version that we might have in Qt. The system should be easy to manage and understand so that we can really build upon it and extend it as we now move forward, to include more and more features and make it more and more fine-grained, and so that you can really configure Qt exactly to what you need. It should also encode, the dependencies between all these different features in one place. And it should be safe to use finally. We've had problems before that we had some things that you could leave out of Qt and usually worked with if-defs in the code. Problem was those weren't safe. You did a typo and suddenly certain parts of the code weren't excluded and you could never see that. We wanted to make sure that that one was safe. So let's have a look at how we did implement all of this. Before I do that, and one of a few more things we wanted to handle there. We wanted to make sure that the system can handle all the command line options that we had. It should run the configuration tests that we have so that we detect the compiler, the operating system architecture, operating system functionality. We detect external libraries, whether they're available or not, and what flags you need to build against them. and then handle all the feature switches, which is actually the piece that we needed most urgently for Qt Lite. How can we make certain functionality inside the framework optional so you can leave it out when compiling the libraries? And of course, we needed also to have a way to report all of this back to the users. So now, how did we implement it? We actually use QMake. QMake is, the tool that we use to build Qt, not to configure it. At least up to 5.7, this was what we did. And we've now extended the scope of what QMake can do to also be able to do the configuring for us. The advantage with QMake is that it's bootstrapped already. It's available very early, in the stages of building Qt as a product. And we can thus use it for configuring. It's available across all our platforms and has a cross-platform syntax. And we don't require any additional tools at build time, which is always a problem because you need to have them installed and you have additional dependencies. It just complicates then, the whole process of building and compiling Qt. And finally, it can easily pass JSON because Qt can do that. And, we wanted to have a human readable declarative format to specify the configuration data. And JSON was one of the candidates that we felt was a good match with that. So we did a lot of work on the implementation and moved then all of the data that was basically, declared or defined in an imperative way in the shell script and the executable into a declarative configure.json file and built infrastructure into QMake and around QMake to basically make sure that we can parse these JSON files, figure out what they declare, what kind of features they offer, how they can configure, how the different command line options should influence how we configure Qt, do the configuration, and then report everything back to the user. Not everything works fully, declarative, so you can have a companion configure.pri file. That's a file in QMake syntax that can be added and to do special handling. I won't go into the details here in this presentation, but you have that option to implement certain special handling there in a declarative way. But if you look at the configure.json file now, it contains several sections. Command line handling of external libraries, handling of configuration tests that basically check for different features of the operating systems. Then the features themselves, which are the things that you can turn on and off when you build Qt. And then, something where we have a report and a summary that is being, printed back to the user. Let's have a little bit of a look into some of the details there. Command line basically contains all the different command line options that you've seen before when you were configuring Qt as a product. Things like Boolean options can easily be encoded there. Options that provide several enums or choices, like for example for PCIe, do you want to use the system version or do you want to use the Qt version? Of course, there's always a fallback. If you don't specify these values, we have a default that will then get used. In case of GUI, the default is yes. In case of PCIe, it means the default is, well, let's run some configuration tests and figure out whether the system PCIe library is available and usable. And if yes, we use that one. If no, not, we use our own one. And so these kind of things you had there, and there's different types of arguments that can be specified, like Boolean values, enum values. We can pass strings and many other arguments on the command line then. Second thing we have is then handling external libraries. And one example here is how we handle the PNG library. This is basically, from the configuration code in Qt base, inside Qt that we're using, where we say, okay, we need to include PNG as an external library. And then we have a test there that basically checks whether we can find the PNG, libpng, and different sources that we basically that influence what we pass to the test. Like, for example, we can have a source called package config, where we ask the Linux package config system for libpng, and it'll give us the arguments that we need. Or we have on MSVC, we know that the library we need to link against is called libpng, not png. The link line is slightly different. So we have different, default link lines that we would pass off to the configuration test to check that one. And we'll try these things in order, and whatever matches will then get used later on when we build Qt. In addition, there are pure configuration tests, like, for example, a test that checks whether the Linux frame buffer is available. And this is a simple compile test. We specify the test here. The configuration system tries to compile the test. If the compilation succeeds, we can compile and link that test application. We know that the Linux frame buffer is available, and we can use that and enable certain pieces of functionality inside the product, depending on this thing. These are the things that you actually will be seeing when you're configuring Qt. There's a label here, and you'll see that as lines when you run the configure in Qt. There's testing for Linux FB, and then the answer comes back yes, no, and that's these tests that are specified here. And now, at the heart of things are actually the features that we're having. Features are really things that we can turn on and off, and then define how different parts of Qt are being compiled, or whether they are getting compiled. Here are two features. One of them is the feature where say, okay, do we have dlopen available? And it depends on that either the tests.dlopen passes, or that we could find libdl on the system that we're compiling to. And we define one output and say, okay, if this isn't available, we'll set a defined Qt no dynamic library, and then we know inside Qt that we can't use that feature. Another slightly different feature, which is when we build, whether we want to make all warnings errors. That's something that we use to keep our source code clean when we build it ourselves as a developer build. So the people developing Qt, when we build it, many of the warnings will be turned into errors, and that's something that we want to have. And there you see that we just output this as a private configuration. Private config means it's not propagated to your projects as a user. It's just being used inside Qt. There's also public config output, which will then mean that the configuration, the feature, will be propagated to you. So how can I use that to create a custom configuration? To create your own configuration, you can enable and disable pretty much everything, every feature that we have on the configure command line. But we have a lot of options, and you can basically enable and disable any feature there, saying minus feature, minus foo, or minus no feature foo. But the command line can get very long, very hard to handle, and you might also easily get into combinations that are sort of mutually exclusive or incompatible with each other. So for that, to alleviate that, as Niels mentioned earlier, we have created the configuration tool. I'll come back to that one in a minute. But there's a second thing that you want to do often as a user, and that is, you want to make your code or compiling your code dependent on these features. So, for example, if a certain feature, let's say MIME types, for example, could be a feature that's a set of classes we have in Qt core. And it's an optional feature in Qt 5.8, and you can enable or disable it. If you don't need MIME type support, you can simply disable it. And then we have two ways of detecting that. One of them is in the profiles of your QMake-based project. You can basically check with the Qt config function whether the MIME type feature is there. So you would write Qt config MIME type, and then you open the scope. If the feature is available, everything inside that scope will get executed by QMake. And you can, for example, add additional source files there, or you can set other things in your project. On the C++ side, we have two macros that help you there. You can either check with the Qt config macro whether the feature is available or not. The advantage here is that these functions are all safe. So if you misspell the feature, you write MIME types with an S at the end instead of MIME type, you would get a compile error immediately. So you will notice when you misspell something, and so that you don't accidentally include code that should not be included. We also have a second macro Qt require feature, which basically translates to a static assertion. At this point in time in the source file, the feature has to be available. If it's not, give me a compile error. Features are also grouped by Qt libraries or modules. So that means features that are, for example, defined in the Qt widgets module. You will not be able to see them in your code unless your project includes widgets and says, I want to really get I'm pulling in some include files or header files from the widgets library. Otherwise you will not see those features, and you will also get a compile error if you try to basically do any decisions or any branches depending on these features. So as I said, as we said before, we have also added a GUI tool to really handle all these features. We have a lot of them now, and we will probably get more of them in the future. And features do have dependencies between each other that are encoded in the JSON files. So for example, you see here certain features that we have, which actually change quite a bit of the size of the core library, like big codecs are all the text codecs to convert from Asian encodings, CJK encodings, to Unicode and back. And if you don't need to handle external data that is encoded in these encodings, and all your source code is, for example, UTF-8 based, all your text input files are UTF-8 based, and you know that you can easily remove, for example, that big codecs feature, and by that save yourself, a couple of 100K in the Qt core library. And you see that there are other features like codecs underneath, which means all of the codec support. So that one, would then implicitly turn off all the different, big codecs, iconv, and other things. And with that, we have, tried to group also these features into a friendly way for you to use. As you see here, you have underneath corelib, we have different groups of features. So it should be relatively easy to find your way and try to turn off these things, the things that you don't need. That tool will, with Qt 5.8, come as part of the Qt for Device Creation product. Currently, we have approximately or more than 150 configurable features that you can use and to tweak Qt. Some of them really turn on and off very large pieces of functionality, like turning on and off OpenGL support, MIME types, SSL support, or for example the interpreter mode for QML, which you don't need if you have the jittered mode or precompiled QML. Some of them turn on and off small individual APIs, like the QRegular expression class or the flippable item in QML. And even others, also provide you certain performance size trade-offs, like we have one feature to whether you want to optimize the SHA-3 algorithm for speed or for size. And the difference in terms of size can be rather large. The optimized implementation, adds 150 kilobytes or something like that to the core library. So there's clearly trade-offs that you can then do and where you can decide what your needs are. So, from you as a user, customer, really Qt Lite and the feature system really enables you to create a build of Qt, of the Qt product that is tailored to your needs. And you can, go the full scale from a very, very small and compact build with very few features, of course, in that case, and down up to, just using a full build of Qt that includes pretty much everything that we have. And you can choose very fine-grained, what your needs are in this area. So you see, you go from a Qt Lite easily to a very compact one. And some examples here are, here's a graph that shows you a little bit of some of the improvements that we can do, that we could achieve with Qt Lite now. Can be, up to 80% smaller than what you could do with a dynamic build in Qt 5.6. So you see in the graphs that we have, dynamic builds and static builds for 5.6. This was actually using one demo application that we had, a small QML-based application. So it was an application that was using, QML and Qt Quick as a user interface and was doing a little bit of things there. They are having some functionality. Now with Qt 5.8, you see that a full dynamic build is pretty much the same size as before. Nothing has changed. But then with Qt Lite, you can basically, and with the feature system, you can turn off all the features that are not actually needed to run that application. And you can see that even with a dynamic build, where you are able to cut the size of the whole stack. That means the Qt libraries that we need, plus the application itself, down, from 25 to around, 9 megabytes. And with a static build, we're getting down to currently to 5 megabytes. And I think we still have some room to improve on that number as we move forwards towards Qt 5.9 and 5.10. So this really allows you to cut out a lot of things in Qt and really create very compact and small binaries. 60% smaller than the static build in Qt 5.6 is what we achieved for this sample application. And that in turn also results in faster application startup times. There's less code that needs to be mapped into memory. You will use less RAM as well, because as said, there's less code that needs to be mapped into the memory. You have the flexibility to really customize the HMI and the Qt library to be best optimized for your use case, as small memory footprint as possible. And we can actually make things really remove things on a per function level in some cases. When you look at, how do I get the smallest build of my application and the most performant one out of it, clearly, static linking is the best way to go. This is what gives you the smallest possible binaries and the best possible performance for your application. And this is very, this is a good solution for many, many use cases where you create single-purpose embedded devices. Some embedded devices, where you have larger projects, require a multi-process architecture, but in that case, you usually, use a lot of the features of Qt, and Qt Lite is probably also a little bit less relevant. So this is what we can achieve with Qt Lite. As you see, we can get significant reductions there in size, and that also implies that we can scale quite a bit better down to lower end hardware. Now, what are we thinking about for the future here? This is ongoing work. We're not done yet. And we will continue this, in the next versions of Qt as well. A couple of things that we are looking into. First of all, we want to extend the feature systems with additional features. make more things configurable that are currently not configurable. We want to also we also had a focus with Qt 5.8 on the core libraries in Qt. And that means Qt Core, Qt GUI, Network, Qt QML, and Qt Quick. We will now work also on extending the feature systems to also cover other areas of Qt, so that you can also use that, for example, to configure functionality in, let's say, multimedia, or maybe even in the Qt web engine, to tailor those to your needs. So that's one area. The other area is, now that we have the new system, we will also increasingly look into runtime memory consumption. Where can we improve that? Can we make certain parts of Qt, the core libraries, or let's say the QML engine, use less memory, and how can we improve on that one? So the second focus for us now will be runtime memory consumption. And then there's a third piece, and that is looking at performance. How can we actually make the code that we have, even also when it's more compact, perform better? How can we improve performance of the product as a whole, performance of individual APIs that you as a user need? So these are the things and the focus that we'll have moving forward, and it's going to be something that will benefit all of Qt. Yes, I mean, the main focus here is on the embedded side, but a lot of these improvements will benefit also our desktop customers, our mobile users. And with that, I think I'd like to thank you for listening in, and I think we're open to questions there, Niels.
Yes, we've gotten a lot of really interesting questions. I've answered some of them throughout this session, so thank you for sending that in. We have some questions. Several people have been asking about whether desktop is a focus or whether desktop is still important to us, and I think you've answered that pretty well already, that there are a lot of benefits also for the desktop users with this change in the architecture, and maybe also especially for the mobile users, being able to ship significantly smaller binaries and making updates available through much smaller binaries is a great benefit for the mobile users as well.
Yes, I would say so. Clearly we have our desktop. Desktop is important. We have many customers using Qt on the desktop, and this is clearly very important. And we're doing continuous work there to improve that. A lot of the work also that we're doing outside of Qt Lite, the C++11 work that we've been doing, new functionality in many areas, are things that are important for the desktop. I think when it comes to Qt Lite itself, there's a large benefit that I'm seeing for desktop and mobile customers. We have redone the whole configuration system to be something that was very hard for us to maintain, to something that's now very relatively easy to maintain, very flexible, and allows us to also integrate much better with, for example, libraries that are existing on the desktop. Makes it much easier for you to configure Qt to the needs that you have, and also build it there for the desktop platforms exactly as you want. So you can use the same system on the desktop.
Exactly. And then there was some questions around the tooling around this, and one of those questions were whether there are any hints or directions regarding the specific memory or byte savings in the GUI tool when you are selecting or deselecting different features.
Yeah, the answer is simple right now at this point in time, no. But it's on our roadmap and something we also intend to add in the future. So it's basically at least some indicator whether this will save you a lot or just a little is something that I think we should have and we should add. But it's not there in 5.8.
No, and I think this connects very well to kind of the development of this project, that we've spent most of the focus in this very big and very heavy overhaul of the architecture itself. So getting those pieces in place have been the highest priority. And then for the next coming releases, we will be working a lot on the tooling to improve the usability of this architecture. So that is one of those things. And there was another great question about Qt Creator support for per project optimization, so that you can manage different versions of Qt for different projects. And there is already a lot of support in Qt Creator for managing different Qt versions. So looking at things like that are things that we will be doing for 5.9 and for Qt 5.10.
Yes, I mean, Qt Creator already has the kit support that allows you to basically define different Qt versions for different targets. And, extending that to also cover different configurations, like, through the Qt Lite feature system, is something that I think would be fantastic to have, and it's clearly something that we will be working on towards when we move now towards Qt 5.9 and 5.10. But as Niels said, I mean, the focus for 5.8 was to get the infrastructure in place and already show what can be done there, show the potential, show a lot of the pieces are there, and then use that as the foundations to move forward.
Exactly. And then there was another question, and I think we've maybe covered this, but regarding the open source versus commercial aspect of this. So I don't know, Lars, if you want to touch on that, even though you probably already have said it.
Well, I think what you can see here is pretty much everything that we have been doing here is part of the open source version of Qt, with one notable exception, and that is the graphical configuration tool, which is currently a commercial feature for Qt for device creation.
Exactly. And then, just a little, I think several people have been wondering what parts of this is available already, what is the future. So all of the things we've covered so far, except for the slide that said the road ahead, all of the features that we've covered so far are part of Qt 5.8 and will be delivered with Qt 5.8. So we are in the works, working right now on putting that out. So I hope this has excited you a little bit to go to our webpage and download Qt 5.8 once that becomes available in a very short time.
And just as a teaser there, it's really just, we're talking of a couple of days until we'll have that one out.
Yes. And since we were talking about embedded for a lot of this, there was some questions regarding cross-compilation. And that is certainly something that is well supported with this.
Yes, absolutely. I mean, this is not limited to just regular compilation. So this works just as well with cross compilation, and we will detect the features for the target that you're compiling towards.
And let me see here. Regarding the QMakeJSON thing, there's a question if this is some kind of package management. I don't know if you want to explain a little bit about that, Lars.
No, it's not package management. No, it's not package management. Package management would mean that you basically go in and you split things up into things like what you have with Debian packages or other Linux packages. You split things up into different binary packages and then you select which ones to install. This is really about configuring, how you build Qt as a product. And of course, you can leave there out certain parts of Qt out of your product, but it is orthogonal to managing packages.
Exactly. And there was a question here if this recording will be available online. So yes, it will be available online. So we will send out an email with a link to this webinar to all of you who attended and to all of you who signed up. So feel free to share that with your friends and family, but maybe most of all your coworkers and other people interested in Qt. And we will also make this available from the Qt 5.8 landing page once we release Qt 5.8. So there will be a link from that you can use to download this webinar from our web pages very soon. We won't send it out right away. We'll take a little bit of time to go through and kind of finalize it. But then we will share it with all of you. Yeah, and then there have been a few questions here on support for other hardware platforms than ARM, such as MIPS, for example. Do you care to say anything for that, Lars? How does this relate to the actual hardware architecture support?
The whole, Qt Lite configuration system is independent of the hardware platform you're working on. ARM is just mentioned quite a bit because it's the most common one. But we do support MIPS, we support, Intel x86, x64 CPUs. Others are also possible, but, then it gets very rare. People have other CPUs than those.
Exactly. And then there are several questions regarding the documentation and where people can learn more about this. And the documentation will, of course, be part, as the product is part of 5.8, the documentation will also be part of the documentation of Qt 5.8. So that is part of that. And the tool as well will be available as part of the Qt for Device Creation product released as 5.8. Yeah, maybe we have time for one more question, so let me see here. There's a couple of questions relating to things like if we will leverage Vulkan API in the future, and I think that is also more or less a separate discussion. We are actually doing some interesting things with Vulkan. The Qt company is a member of the Kronos group, and we are investing into this, but I think that's somewhat tangential to Qt Lite efforts as such.
That would be a topic for a full webinar of its own, I think. But I mean, I can give a 1 minute, or a very short statement here. I mean, we've done quite a bit of work with Qt 5.8 to actually make certain parts of Qt more independent of the underlying graphics APIs, i.e. more independent of OpenGL in this case. And we have been doing some, test implementations, for example, of implementing the QML scene graph on top of Direct3D 12, which is, conceptually relatively similar to Vulkan. Vulkan is clearly also possible. Haven't done it so far, but this is something we might be looking into more in the future. We'll clearly do work there to make sure that we integrate well with Vulkan.
Yeah, and then there's a question here if this means that the GUI tool won't be available for desktop and mobile. And yeah, unfortunately, this is the case that for the 5.8 release of Qt Lite, the GUI tool for configuration is focused on embedded only. But that does not mean we only focus on embedded for this. We are looking into how we can add more value also for the desktop and mobile platforms. We see a significant advantage of using Qt Lite also on those platforms. So for the roadmap, this is a priority and something we will be looking into. So unfortunately, it's not there for the first release, but it does not mean it's not something we are going to work on. So I want to make that clear. Yeah, I think there's most of the questions have been answered, and we are more or less running out of time. So we will get back to all of you, and please don't hesitate to send us an email if you have further questions that have not been answered so far. But with that, I think maybe it's time for us to say thank you very much for listening in, and I hope you have enjoyed it. I hope you've learned something, and I hope that you're looking forward to downloading 5.8 pretty soon and getting started with this.
Yes.
So thank you very much, Lars, for for everything.
Thank you. Also, thanks from my side. Thanks for taking the time to listen to us, and I hope you'll have a wonderful rest of the day or evening. Thank you very much.
Yeah. Cheers. Have a nice day or evening, guys.
Thank you and goodbye.